right, so 5.2. So, um, histograms, okay? Now, for histograms, what you guys should know about them is they're like a bar graph, but what they do is they show frequency, okay? So basically, this is just a fancy bar graph that shows the frequency of an event occurring, okay? So this is a way to display frequency, and by frequency I mean the amount of times so the amount of times an event has occurred. All right. And this is important in statistics because it's all about counting your data, right? So, you would count up the amount of times somebody, how many people, scored between a 60 and a 70 on a test, or amount of people that own 1 or 2 cars, or own more cars, or have 3 kids and 5 kids, or whatever. Whatever kind of data you're collecting, this is a way to organize it. It's basically just a bar graph that counts frequency, or the amount of times. Okay? So let's see here. I'm going to try to get an example to start with. Let's do an example here. Okay, the following marks are collected from a Foundations 20 math final. We're going to make a histogram to display this data. Okay, so what I'll do is I'll put up the numbers, and then I'll go through the steps of making a histogram. Okay, it's pretty straightforward once you see it. Okay, so let's write out data, and I'll even list this one from highest to lowest, or lowest to highest, so it's organized a little bit easier. Often you're not going to get that, so you kind of have to group everything together accordingly. A couple kids not making more. Ah. Thanks for the patience. Well, this is way more than you guys, right? I'm making up the data here, so it just makes it. Yeah, I'm not saying like, oh, there's Ethan. No, Sam's not too far behind. Oh, and Bree so close, but no, I'm not like labeling you guys here. Don't worry. They won't let me do that.
We want to test you.
What's that? No, they'll be marked. That's true. I can't say that for sure. This could be. We're going to say underneath it right here. Okay. Now, here's all your data. Okay. So now what you have to do, I'll do all of my work this time so you can see everything. And then if you think you can like cut some corners to make it a little bit quicker, go right ahead. So what I like to do is you need to set up your intervals. So this is your ranges of data. Okay. So I'm going to go up by tens. Okay. So people who score from 0 to 9, 10 to 19. You guys see how I'm going from like 0 to 9? Which you can do after all. The 60s. Okay. So these are your intervals, okay? So this is how many of each that you'll have. You count out the frequency. And you count out the frequency for each one. So how many people scored between 0 and 9%? Yeah. Same. The first four, 1, 2, 3, 4 are all the same. But now, how many people scored between 40 and 49? Right. See here how with my intervals I have defined limits, right? 40 to 49. So if someone scored like a 49.5, that would count it as higher than 49, so it goes into the 50s. Okay, we'll talk about that in a minute here. In the 50s, I had 2. 60s, how many did I have? 5, good. In the 70s. Okay. And then in the 90s, I had 1. All right, so these are my frequencies for each group. Oh, 2 in the 80s. And then 1 in the 90s. Okay. Well, now you got to draw the histogram itself. Okay, so the histogram musts. These are things you have to include. Titles and labels. And no spaces between bars. So we've counted all our data. Here it is. We have our intervals and our frequency. Your intervals are always your x-axis. The frequency is always the y. Okay? this up a little more. Now my intervals were going up by the tens, right? So my first group was from 0 to 9, 10, 20, 30. Okay. And my intervals range anywhere from 0 to 5. On the frequency set, I went up to 5. You could go up to 6 if you want, just so you go past it a little bit. It's up to you. But doesn't matter. Now, to draw your histogram now, you just go to each interval that you have a data point and you draw it. Okay, so at the 40s was my first set of data. How many people scored in the 40s? 3. So you're at 40. So it starts at 40 and ends at 49, right? So the 3 mark, right? And you shade it in. Okay. Now, how many people scored between a 50 and a 59? 2. That's here. See how I don't have a gap between the bars? They're all smushed together quite nicely. Do you do histogram? No, that's from a 60 to a 69. I'm just quickly shading them in. It doesn't have to be perfectly etched or anything like that, okay? 70 to an 80? Anyone besides Ethan? 4. 4? Cool. Boom. Is this making sense what I'm doing here? Pretty straightforward, right? Yeah. All right, and then from an 80 to a 90. 2. And then finally, how many people got higher than a 9? And there's my histogram. Now, remember I also said you need to have titles and labels, right? Your y-axis is always the same. It's frequency. So you just put F-R-E-Q. Frequency. Down below, these are students' final marks. These put marks. They are in a percent. You put like the unit in brackets. And then you need a title above. Say, Foundation 20 final marks. So what this does is it just shows everything in a nice, neat fashion. So I can be like, okay, I can see here between most of my kids scored between a 60 and a 70. 5 of them did that. Cool. So it just kind of lays it all out there. Okay, so the big things to remember are title, labels, and no spaces between lines. Okay, then you just kind of draw a regular graph. You just have to be careful coming up with your intervals. Okay, you have to know where one starts, but more importantly, where the one before that ends. Because you're going to have to split data up. You can't double count your data. Okay? If you guys could turn to page. You look at example number 2. Are you on page 218? Let's talk about that for a second. So the magnitude of an earthquake is measured using the Richter scale. Have you guys heard of the Richter scale? Like a 7.5 on the Richter scale. Sam, you've lived a sheltered life. What can I say? It's how they measure earthquakes, okay? The bigger the number, the stronger the earthquake.
We do live in an earthquake area. So.
Yeah, it's true. We do hear about it. Fair enough. You got me there. Well played. Well played. Okay, so what this has below is a histogram for the frequency of earthquake magnitudes in Canada from 2005 to 2009. So, Vancouver area. There was one in Red Deer last week. Yeah. Oh, yeah.
On the
Like
radio,
Alberta?
Yeah.
on the radio, it's saying that 5-year-old kids were freaking out because there was no Wi-Fi.
Wait, how is that even happening?
With an increase in fracking that we've been doing to mine oil or pump oil out of the ground, by breaking up the bedrock and stuff to get at the oil, it's causing seismic shifts in the ground. So, oh yeah, there's been quite a few of them in interior Canada lately.
There was an earthquake when I first moved here.
Really? Wild. When I taught in Abu Dhabi, we felt the aftershocks of an earthquake. All of a sudden, the projector started going back and forth. And then all of a sudden, everyone started going back and forth. It was pretty freaky, actually. It's the first time I ever felt like the earth below me moved. So, very, very eerie feeling. So, it shows here, like, from the purple, the yellow, the green, the red, and the blue histograms are all different years on page 218. So it wants to know which of these years could have had the most damage from earthquakes. So if you look below those histograms, it has a table saying understanding the Richter scale. So anything less than a 3, you don't feel anything. From a 3 to a 3.9 on the Richter scale, it feels like a truck's going by your house. You might have a little bit of a shake, but that's about it. From a 4 to a 4.9, felt by nearly everyone, movement of unstable objects. Then it kind of just gets progressively worse. So anything on a 5 on the Richter scale, considerable damage to weak buildings. From a 6 to 6.9, difficult to stand, so might throw you around a little bit. Partial collapse of ordinary buildings. And then from a 7 to a 7.9, you're going to have loss of life and destruction of buildings. And then anything higher than a 7, widespread loss of life and destruction, okay? So what it says is every time you increase, the unit increases on the Richter scale, it represents an earthquake 10 times more powerful, okay?
Is anything ever go over 7?
There's been like 8.3s and 8.5s. They get some bad ones up in Alaska because they're right there on the edge of the Pacific Plate, and in South America, like Chile and stuff. So there's been some pretty bad ones, yeah. and Japan's had some good ones too. So if you look here at the data, we'd want to know which of these years had the most damage from earthquakes. So we want to know anything, where did we see the most, like 5s and higher? Okay. So you'd have to go through and you'd have to count them all. Or you could just look at the data. Can anyone, just by looking at the histograms, tell me which one was the year that had the most damage from earthquakes? Yeah, definitely 2008, right? If you had, I'm going to say 5, that were, between a 5 and a 6, and then another 4 that were between 6 and 7. So 9 in total. Yeah. Now, if you look, like, which year had the most earthquakes, period, though? I was going to say 2005. Yeah. Because if you look, it had 20 that were between 3 and 4, and then 11. Yeah, so there you're looking at frequency. So you can see, you can count like the amounts, or you can count for like intensity and stuff for. So you can see how this is a nice way to keep track of all your data, right? Okay, so what I'll do is I'm just going to give you guys some to work on. Now, I don't want you guys to do any frequency polygons that it's asking for. I just want you to draw some histograms today, okay? So on page 2, page 222. Hey, look at that. 222. Do 3 to 5. Okay. So it's going to say make a frequency table first with the data. That's what we did here. We made a table. And then, so that's part A of every question. Then part B wants the histogram drawn. So you'll draw some kind of histogram, and then it's going to ask, C is going to ask some question about the information. So if you guys can do that today, cool. Okay, any questions? Good. Good work.